What we're talking about today is exponents with negative bases. This is directly after your introduction to exponents. So, something we have to remember. In the previous video, we talked about the positions. The two positions is the base and the exponent. Only the thing in front, directly in front of the exponent is the base, and the keyword is only the thing directly in front of the exponent is the base. So we have three examples here of a value or an expression with an exponent. We see here we have a to the third. A is the base. 3 is the exponent. Here, we see that we have the exponent of 3, but 3 is hooked up to this set of parentheses. So that means everything in parentheses is the base. We only have a inside of parentheses for this one. So it's not too much different from the first example, but we do have to remember that if there is anything else inside of parentheses here, that would also be included with the base. And our last part here, here's where it gets a little confusing. We have 4a to the third power, or parentheses a to the third power. The confusing part here is that only this parentheses a is the base. So the base is just what's in parentheses because the 3 is attached only to the thing directly in front of the exponent. So 3 is attached to a, or this set of parentheses, is the base. This part right here, this 4 is not the base. It would be called a coefficient. So, and we know that 3 is the exponent. So the title says that we're talking about exponents with negative bases. We're going to start bringing in negatives pretty soon, but I want you to make sure that you understand what is the base and what's not. So if the negative sign is not in the base parentheses, meaning that we have the exponent directly attached to a set of parentheses, it is not part of the base and has to be brought in later. So if we see something similar to negative 3 squared, the negative sign is not part of the base because the base is only what's directly next to the exponent. So only 3 is the base in that one. The negative sign would have to be brought in later. But if the negative sign is in the base parentheses, it is part of the base and has to be included in the evaluation. That's when you're just solving for what it equals or what it's worth. So if we see something like this, where we have parentheses negative 3, and all of that is in parentheses with an exponent of 2 attached to it, we would say that negative 3 is the base. So something you have to remember is that we have rules for multiplying negative numbers. If the numbers have the same sign, meaning that they're both positive or both negative, the product, which is the answer to multiplication, will always be positive. If the two numbers have different signs, one's positive and 1 is negative, the answer will always be negative. Important to remember those rules. Let's look at two examples where we have a base in parentheses and then a base without parentheses. So our base, we look, we say, oh, here's the exponent. The base is whatever is directly in front of the exponent. So we see this set of this parenthesis in front of it. That means -2, since the negative sign's inside parentheses, -2 is the base. So we would evaluate it like this. We look at the exponent, we say, oh, that means we have 4 blank spots. And since the base is -2, we'll put -2 in each spot. Now I chose to put the parentheses with it to try to make it easier for you to understand where the base is coming from, why I have the negative with it. It won't necessarily always be in there though. Now let's look at it like this. So we have 2 times 2, or I should say -2 times -2 gives us +4 because the symbols are the same, they're both negative. Then we have, well, actually I'll write them down here. So we have +4, we still have times -2 times -2. If we keep going, we say, okay, +4 times -2 gives us, well, now it's a positive times a negative, so that multiplication gives us -8. -8 times -2 is going to equal, since they're both negative, it's going to equal +16. So we end up with a +16 in this case. Look at why this is important. Look at the difference here. Here we see how we have 2 outside, or 2 is not in parentheses. I should say maybe -2 is not in parentheses. We need to remember that the base is only what is directly in front of the exponent. This negative sign needs to be included later in the evaluation. So let's drop it down and use it, well, save it for later. So negative. Now to organize my thoughts, I'm going to put, well, first off, I'm going to put a little space holder right there. But for my base, I'm going to put my base in parentheses. I should say instead that I'm going to show my steps to evaluate the base and the exponent in parentheses. So let's see, in parentheses I have an exponent of 4, so 1, 2, 3, 4 spots. The base that goes in them is just 2. Remember, just 2 is the base. So let's do this. On my next line down, I'm going to drop down my negative sign. I'm going to put a placeholder. We'll fill in this placeholder in that step. Now let's talk about 2 times 2 times 2 times 2. We want the evaluated form of that. So let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th is 16. Here, so 16 is the evaluated form. We will no longer have an exponent. Here is where we have to fill in this placeholder. The reason I put this placeholder here is because I want to remind you that if there is no number in front of parentheses, there is an invisible 1. So this is actually an invisible negative 1. So we have negative 1 times whatever's in parentheses, which is 16. And that is going to equal negative 16. So our evaluated form, our final answer, is negative 16. See how that compares to the answer we had previous. Even though we had negative 2 to the fourth, because it was in parentheses, that made it become a positive 16 because of the way we evaluate it. When it's not, we get a different answer. So it's important you remember that if the negative is not included in the base, you have to evaluate the base first and then multiply by the negative 1 later.